This is question number 13 from the 3.3 MyLab Math homework. So we're given a function and we're being asked to find the derivative of the function. We're being asked to find f prime of x. And then we're being asked to find the values of x where the derivative is equal to 0. And that's what we're going to focus on today in this video. The original function is given to us as a product of a linear binomial and a quadratic binomial. So if you wanted to, you could apply your product rule to find the derivative of the original function. Or since both of these binomials have understood one exponent, you could go ahead and FOIL or distribute, multiply out all those terms. You'll end up with a 4-term version of the original function, and then you bypass that product rule altogether and just do your power rule. But either way, you're going to end up with this derivative. And we need this derivative. We're going to set this derivative. We're asking ourselves, when does this rule, it happens to be a quadratic trinomial, so when does this rule equal to 0? So I'm going to put a question mark above that, because what we're being asked to find are the values of x, like what x values can I input into this function, so that when I follow this rule, the output comes out to be 0. So it's going to output 0 there. Okay, now there's a couple ways you can do this. Since it's a quadratic function, you can use the quadratic formula. And since that always works for every quadratic, I'm going to do that first. So the first thing I can do is my quadratic formula. Okay, so here's our quadratic formula. It says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we use this formula when you have a quadratic function set equal to 0. And what the quadratic formula does is it finds those values of x, tells you what x equals, those inputs. That's what it's calculating, the inputs that would create an output of 0. So you can only use this quadratic formula if you have a quadratic function, which we do, and if that quadratic function is set equal to 0, which it is. So let's go ahead and pick out our values here. So the a is the value in front of the x squared term, so our a is going to be a 6. The b is the value in front of the x term, so our b is going to be a negative 18. And the c is the constant value there at the end, so our c is a 12. So I would say x equals negative b. B is already a negative 18, so you have a double negative. Plus or minus the square root of b squared. It's a negative 18, so I'm going to put it in parentheses to make sure the entire negative 18 gets squared. Minus 4ac, so that's 4 times 6 times 12, all over 2a, so 2 times 6. Okay, then we'll keep just simplifying this down. Okay, so what does that get? That gives us x equals positive 18 because we end up with a double negative there. Okay, then we have plus or minus the square root of what? So I'm going to type all of this radicand, the expression under the radical sign is called the radicand. I'm going to type all that into my calculator and see what I get. Okay, when I type that in, I got 36, which is a perfect square. So the square root of 36 is going to be 6. The principal square root of 36 is going to be 6. Since we're getting a nice integer value, a whole number value when we're taking the square root there, that means I could have factored the original expression from the beginning. And we'll see that in a minute, but here we go. Okay, so all that is over 2 times 6, so 12. So let's keep simplifying that down there. That's going to be 18 plus or minus 6. The square root of 36 is 6, all over 12. So one time I'm going to calculate the x value by adding the values in the numerator and then dividing by 12. And one time I'm going to get a value of x by subtracting the values in the numerator and dividing by 12. Okay, so let's see, when I add those values together in the numerator, that's going to be 24. So when I divide by 12, that's going to be a positive 2. So one of the x inputs that would create a derivative of 0 would be 2. And the other time, let's see, I would subtract the values in the numerator, that's 12. So 12 divided by 12 is going to be a 1. And let's just double check those values real quick. I'm going to come back up here to my derivative. So my derivative rule says I do 6 times the input squared minus 18 times the input plus 12. Okay, so let's plug in these values we got and see if it actually gives us an output of 0. So I'll start just by plugging in, let's plug in an input of 1. So that'd be 6 times 1 squared minus 18 times 1 plus 12. And when I put all that in my calculator, it's going to give me an output of 0. So that one works. And then now I'll input 2 into the derivative. So that would give me a 6 times 2 squared minus 18 times 2 plus 12. And again, when I type all of that rule there into my calculator, I get a 0. So they both work. So the two values of x that make the derivative 0 are 1 and 2, positive 1 and positive 2. I believe my math lab has you type those in, separating them with a comma. So I would type 1, then put a comma, and then a 2. Now, this quadratic formula only worked because our derivative happened to be quadratic, and we were setting it equal to 0, right? So let's look at a more general way to find where the derivative equals 0 using what we call the zero product principle. Okay, so the zero product principle. So we apply this when we have a function equal to 0. So right now we have a derivative function set equal to 0. So what we're going to do is we're going to factor the expression, okay? And then you set the pieces, the factors, you set each factor equal to 0. So equal to 0. So let's see that in action over here. So I have this derivative, 6x squared minus 18x plus 12. And your first step in any factoring, any expression, is ask yourself, is there a GCF for all the terms from the very beginning? And in this case there is, because they're all multiples of 6. So I can factor out a 6 here. And what that does is if you factor out that GCF, the more you can factor out, like the bigger GCF you can factor out, the smaller the remaining, the coefficients of the remaining terms will be, and it's just easier to factor with other methods. So if I factor a 6 out of the first term, that's going to leave me with an x squared. And then I factor a 6 out of the middle term, and that's going to leave me a minus 6x. And then when I factor a 6 out of the last term, that's going to leave me with a plus 2. I messed up the middle term. 18 divided by 6 is 3. There we go. Okay, so 6 divided by 6, if you're factoring out, you're doing the opposite of multiplication. So if I'm factoring out a 6, 6 divided by 6 is 1, so there'd be a 1x squared left. 18 divided by 6 is 3, so there'd be a 3x left, and 12 divided by 6 would be a 2. Okay, so I factored out my GCF, and then I have a trinomial left over that's pretty easy to factor with guess and check because there's a leading coefficient of 1 in front, or you could always use the AC method. So you would factor that however you're most comfortable, but your goal is to get a binomial times a binomial. And these numbers, especially since we factored out our 6, they're pretty easy to work with here. So I'm going to use my guess and check, but again, you could use AC method. So if you need to brush up on factoring, Google AC method for factoring. I'm going to use a guess and check method here because the leading coefficient is a 1. So I know x times x will give me an x squared, and I know 2 times 1 are the only numbers that can give me this 2 back here. And they need to multiply to a positive. So either these terms would both be have addition in them, or because a positive times a positive is a positive, or they would both have subtraction. And that's the one I'm going to need because I'm ending up subtracting that 3x. And then you could FOIL that out or distribute it to check. Okay, so once we do that, we are setting this equal to 0. Okay, so what the zero product principle says is if you multiply 2 or more things, and the result is 0, one of the things you multiplied has to be 0. Okay, so either the 6 is going to be 0, but 6 is a constant. It can never equal 0, so we don't even consider it. Or the binomial x minus 2 is going to be 0, and that can happen, right? What would x have to be so that x minus 2 is 0? Well, x would just have to be a positive 2. So if x is a positive 2, 2 minus 2 would be 0. And 0 times anything is 0. So that's one possibility. And then again, the binomial x minus 1 could be 0 if x is a 1. 1 minus 1 would be 0, right? So we got those same two answers from when we did quadratic formula, 1 and 2. And you don't need to know this for test 2, but it'll come up on test 3. So what I'm going to do is just pull up Desmos real quick and graph the original function and just show what it means for the derivative to be 0. So let me jot this down real quick. It is 2x minus 9x squared plus 6. Okay, let's go to Desmos and let's graph that real quick so I can show you what's actually going on here. So Desmos. Okay, so I'm just going to graph that. So my function is 2x. This is the original function that was given to us, not the derivative. So x squared plus 6. Ooh, and that looks awful. Probably have to zoom out. Oh, there it is. Wait. Oh, way down there. Yuck. The reason why this is looking so yucky right now is my x values are going from negative 100 all the way up to like positive 100. And we know what our x values are. We're only doing this to check, right? We know our x values are positive 1 over here, positive 1 and positive 2. So what I'm going to do is just change my settings here to kind of zoom in. So on my x-axis, I'm going to just go, I don't know, let's go from like negative 12 to positive 12. Yeah, there we go. We're just going to zoom in a little bit. And then what I can see here is, let me plot those points real quick. Let's plot the point where x is a 1. Okay, and then let's plot the point where x is a 2. Okay, and then what we can see here at these points, if I zoom in a little bit, is our tangent line goes horizontal at those 2 points. Remember to have a slope of 0, you have a horizontal tangent line. So let me just snap this so I can draw on it real quick. Okay, so what's happening here is when x was a 1, I know I cut off this up here, way up here, the x-axis, that was x equals 1. This was x equals 2. This line was x equals 3. Okay, so at x equals 1, I can see that I would have a horizontal tangent line there. So up until that point, my tangent lines had been positive, positive. They're starting to flatten out. And then it goes flat there. So when x is a 1, I'd have a horizontal tangent line. And then the tangent line starts to tip negative a little bit, just slightly. But then again here, when x is a 2, that tangent line would go flat again. And then the tangent line would start to pick up and go more and more positive after that. So when x was a positive 2, I hit that horizontal tangent line again, that slope of 0. So we were finding those points. We were just doing it algebraically. And since our derivative was a quadratic, you had two choices, quadratic formula or the more generalized zero product principle. Okay, if you have any follow-up questions, just shoot me an email.